Hi guys, my name is Neel. I am an intern at the Sparks Foundation. Today I've been given a task that is prediction using machine learning, unsupervised machine learning. And in this task, I have to predict the optimal number of clusters of the data set. And and the data set consists of three types of flowers, namely Iris-setosa, Iris-versicolour, and last is Iris-virginica. And to complete this task, I have to follow the 5 steps, that is importing the dataset, second is visualizing the dataset, third is finding the optimum number of clusters, fourth is applying k-means clustering on the data, and fifth is visualizing the cluster. So step 1 is importing the dataset. So in step 1 I have used matplotlib, pandas and scikit-learn clusters for importing k-means. And first I have just taken the URL and read the CSV file using pandas. And second I have just used head and tail function to get the first five and the last five data from the dataset. And I've just moved to step 2 for visualizing the data. And in this, first I found the shape of the dataset, that is 150 rows and 6 columns. And then I've printed the names of the columns using df.columns. So it has given the all the names, that is six column names, that is sample length, sample width, uh, petal length, petal width, and species. And then it has that I have found that how many species are there which are unique. So it has given me three names, that is Iris-virginica, Iris-setosa, and Iris-versicolour. And data type I have given, it was given as object. Now I found the information of the data set, and it has given me all the not null and column names and data type values for each column in the data set. And then I've described for finding out the mean, count, and all the mathematical calculations, which is min max of all the six columns. And finally I've just removed uh, the unneeded columns. I've just So step 3 was finding the optimal number of clusters. Here I've used the elbow method. So in this method, number of clusters are varies within a given certain range. For a number within the cluster, sum of square value is calculated and stored in a list. These values are then plotted against the range of number of clusters used before. The location of band in the second plot indicates the appropriate number of clusters. So let us understand that what I've done. So I've formed clusters from the range 1 to 15. And basically it is just the inertia of the clusters. And I've just plotted it against the graph of number of clusters, and within the cluster sum of squares. So let us also explain what is elbow method. So as elbow method says that the point from where the graph becomes constant, you need to select uh, the number of clusters at that point. So as we can see, point 3, which is this point, which is point 3. So some of the clusters, the number of clusters is needs to be 3. So from here we can see that the graph is getting constant and there is no ups and downs and doesn't decrease significantly. And also there are no noise in the graph seen as such. So yes, we can select this point. uh, and One might be thinking that why we have not used point 2. So yeah, as you can see, there is a significant decrease from this point. Hence we can't use point 2. So the clusters can't be 2. And also as per our data also, we can say that there must be 3 clusters because we have 3 objects, the 3 flowers. And hence we can clearly see that this is the elbow method. And that's it in this step. Now we move to the next step. In this step, I have to just use number of clusters, which is 3. And number of iterations is 300. And I've just predicted the model. and later I've just visualized the data using the three colors for each flower. And red color is given for Iris-setosa, blue is given for Iris-versicolour, green is given for Iris-virginica. And here we can see that the yellow dots are the centroids, and the green color is the area, which is for the virginica, cluster for the flower virginica. And for red we can see the centroid is over here, and same the color is given for the Iris-setosa, the cluster color. And same like for Iris-setosa, the blue color is for Iris-setosa, and the cluster has its centroid over here. And we can also analyze one more thing from this, that there are some outliers in these graph, like this point for the Iris-versicolour and this point for the Iris-virginica, which it has considered in the cluster, but actually it is like kind of a outlier, and hence this is also a drawback for the k-means clustering, that the outliers are not outliers are also included in the cluster. So hence this was the task 2, and please give your valuable comments in the comment section. Thank you.